We've all done it, right? You pop a pill for a headache and just trust that it's going to work. It seems so simple. But that tiny little tablet is actually kicking off one of the most complex journeys you can imagine, a hidden adventure happening right inside your own body. So today, let's follow that pill and see what really happens. It's a question we almost never think to ask. You just swallow it and expect to feel better. But what's going on in that in-between time? Well, it's definitely not magic. It's this incredibly precise, multi-stage process, all governed by some pretty fascinating science. Okay, let's jump right in. So, our pill's journey actually begins way before it gets anywhere near its target. See, whether a drug actually works or not is decided by a whole series of handoffs, kind of like a microscopic relay race happening inside you. Think of this table as our roadmap for the journey. It all starts with pharmaceutics. That's basically the science of just designing and making the pill itself. Then it gets handed off to biopharmaceutics, which is all about how that pill breaks apart and releases the drug. After that, pharmacokinetics kicks in. That's what your body does to the drug. And finally, the last leg of the race is pharmacodynamics. That's what the drug does back to your body. Each step is absolutely crucial. Okay, so the pill has been swallowed. Its first major challenge? The actual medicine, the active ingredient, has to break free from the very thing that was designed to carry it. This is what we'll call the Great Escape. And this whole escape is managed by that science we just mentioned, biopharmaceutics. It's the critical link between the physical pill you swallow and the active drug that your body can actually use. It's all about making that medicine available for action. And this escape, it happens in two main parts. First, the pill itself has to fall apart to disintegrate and release the drug. Think of it like a tiny package bursting open. Second, that drug powder has to dissolve into the fluids in your body, turning from a solid into a liquid solution. And here's the thing, this part is a total non-starter. It's non-negotiable. If the drug can't get out of the pill and dissolve, it doesn't matter one bit how powerful it is. It's just going to pass right through your system without ever doing a thing. The journey is over right then and there. All right, let's assume our drug pulled off the Great Escape. Awesome. But now it's facing its next big barrier. It has to get out of your digestive tract and onto the body's main transportation highway, the bloodstream. This critical step is called absorption. This is the moment the drug officially gets into your system. It has to cross through the walls of your gut to get into your circulation. It's kind of like a passenger having to go through a security gate to get onto a train. And believe it or not, we can actually measure how successful this step is. The measurement is called bioavailability. It tells us exactly what percentage of the drug from the pill actually made it into the bloodstream, ready to go to work. So a high bioavailability means that absorption process was super efficient. Once it's in the blood, our drug is off on a grand tour of the body. But this is no vacation. Its every single move is tracked and managed by a whole other field of science, pharmacokinetics. Right, so pharmacokinetics. It sounds complicated, but it's really just the science of what the body does to the drug. And lucky for us, it's often summed up by a really simple and powerful acronym, ADME. Let's quickly break down what each of those letters means. First up, A is for absorption, which we literally just talked about. That's the all-important first step, where the drug gets onto that superhighway, the circulatory system, and officially kicks off its grand tour. Next is D for distribution. Once it's on that highway, the bloodstream carries the drug all over the body. It's like a microscopic delivery service, dropping off little packages of medicine at all your different tissues and organs, hoping to get enough of it to the one place it's needed most. Then comes M for metabolism. Now, your body is smart. It sees this drug as a foreign substance, and it immediately starts working to break it down. Your liver is the main processing plant for this job. It chemically changes the drug, usually to make it easier to get rid of later. And that brings us to the final letter, E, for excretion. This is the cleanup phase. The drug, which has now been metabolized, gets filtered out, mostly by your kidneys, and eliminated from the body. And that completes the drug's entire life cycle inside you. So, we've just followed this unbelievably complex journey from start to finish. But let's get down to it. Why does understanding all these little steps actually matter for our health? Because here's the most important part. This journey is never, ever the same. It can change based on the drug itself, how the pill was made.